On to momentum. So, another conserved quantity is momentum. An object's momentum is simply its mass times its velocity. Remember, momentum is lowercase p equals m times v. Note that there are not different types of momentum the way there are different types of energy. Momentum is simply mass times velocity. Note also that momentum is a vector, which means it is positive for right or up motion and negative for left or down motion. The direction of momentum is the same as the velocity, so negative velocity means negative momentum. Negative velocity does not necessarily mean slowing down. It means that we're moving in an opposite direction. On your equation sheet, it's going to look something like this. The equation for momentum appears here, that both p and v are vectors. The direction of p is the same as the direction of v. Momentum is conserved during any interaction when two objects push each other. There are two types of interactions like this. Collision, two objects that are initially separate come together and push on each other when they touch. And an explosion, two objects that are initially touching then push each other when they're apart and separate. This is not necessarily a chemical reaction. Two ice skaters initially together and pushing on each other as they come apart is an example of an explosion in physics. So a collision is when you start with two objects and they crash. They're either going to do this and stick together, or they're going to crash and separate. Another way to look at it would be an explosion. An explosion where you start with one object, something happens, and then boom, they're apart. Conservation of momentum example. If we have a blue 4 kilogram cart initially moving to the right with a speed of 6 meters per second, collides and sticks to a red 8 kilogram car initially at rest. What is the final speed of the two cart combination? Initially, the blue cart has momentum while the red car does not. Because the 8 kilogram is at rest, the velocity is 0, and we know that momentum, p, equals mass times velocity. If our velocity is 0, 0 times the mass gives us 0 momentum. So only the blue car has momentum. The initial momentum is 4 times 6, so 24 kilogram times meter per second. There's no special name like there was for energy with a joule. It's just a kilogram times a meter per second. Finally, the two carts move together so we can treat them as a single 12 kilogram object. Because we don't know the system's final velocity, we just say the final momentum is 12v. So 12 times the initial velocity. 12 times the final velocity, excuse me. Set the initial momentum equal to the final momentum. Okay, so with conservation of momentum, you'll see these subscripts can get messy. So it's important that you take your time and you really organize your thoughts before solving one of these. We have the mass of the blue times the initial velocity of the blue, that's the I. That's the I here. Then plus mass of the red plus the initial velocity of the red equals the mass of the blue plus the mass of the red times the final velocity. Because we start with two objects, we have object 1, object 2, and then they come together and the two masses join. So object 1, object 2, they come together and the two objects join. 4 kilogram, the next step is just plugging in the numbers. 24 equals 12v. Guess what the final velocity is? 2 meters per second. Here we go with a little cartoon. 6 meters per second, hitting something at rest, and they both come to 2 meters per second. Let's look at another one. A blue 1 kilogram cart is initially at moving to the right with a speed of 6 meters per second, collides with a 2 kilogram cart initially at rest. As a result of the collision, the blue car comes to a rest. What is the final speed of the red car? Initially, the blue car is the only one with momentum because the second car is at rest. Rest means 0 velocity. So that means no velocity, no momentum. Its initial momentum is 1 times 6 kilograms times meter per second. Finally, the red cart has all of the momentum. Because we don't know the red cart's final velocity, we can just say final velocity is 2 times the mass times the final velocity. We'll set the initial momentum equal to the final momentum, like so. Mass of the blue times the initial velocity of the blue plus mass of the red plus the initial velocity of red equals, ooh, this is different. So we start out with 2 objects, and then we end up with 2 objects. So this time we start off with object 1 and object 2. Object 2 is at rest. Object 1 is moving, crashes, and then they're both going to move in the same direction probably, but they'll separate. And let's see, once we plug in our numbers, we get 1 times 6, mass of it. Then the red car is at rest, so 0 momentum there. The blue car ends at rest there. That's what I meant, not moving together. Well, let's see the cartoon now. All of the momentum goes into the red car. So let's try it again. This time it's your turn. We've got a blue kilogram car moving to the right with a speed of 6 meters per second, colliding with a 2 kilogram car at rest. As a result, the blue car comes to the rest. So we know the initial speed of the red car is at rest, and the final speed of the blue car is at rest. What's the final speed of the red car? We like rest because that means something's going to turn to 0 and things get canceled out. So that's very useful for us. Initially, the blue car has momentum. Its initial momentum is 1 times 6 kilogram meters per second. Finally, the red car has all of the momentum. Because we don't know the red car's final velocity, we just say the final momentum, mv equals 2v. Set the initial momentum equal to the final momentum, as usual. And what do we have here? So all of this junk will go to 0, all of this junk will go to 0, and we're left with 1 times 6 equals 2 times v. And then our velocity is just 3 meters per second to the right. Here's the whole thing. Here it comes. Look out. Collision. This is what we call an elastic collision. 2 objects start off, and then 2 objects end up. A red 4 kilogram cart initially moving to the left with a speed of 6 meters per second collides with a blue 2 kilogram car initially at rest. As a result of the collision, the blue car moves to the left at 8 meters per second. What's the final speed of the red car? Well, only the red car has momentum. Its initial momentum is 4 times negative 6. Negative because we're moving to the left. Okay. And finally, both cars have some momentum because both are moving. We can't treat them as a single combined object because the carts might be moving differently. Did not say that they stuck together. If they do stick together, if the mass is combined like they did in the first example problem, then it'll be explicitly told to you. Now we'll set the initial and final momentums equal to each other. So it's the same big long equation we've been dealing with, and then we plug in our numbers. That goes to 0, and then that's it. So we have 4 times negative 6 equals 2 times negative 8 plus 4v. Using algebra, add 16 to both sides, divide by 4, we get final velocity of the red car to be 2 meters per second, and here's our animation. That's it. Pretty cool. An explosion will be the last video.